But I should have asked, Marina, any questions before we get started? Particularly because it's we got a little more no questions of our okay, perfect. Well then, yeah, like I was telling you, I think this will be a uh nice sort of more I guess private, relaxed sort of thing. Um, all right, let me share screen. Actually, I could ask you guys some stuff. Well, let me ask if we have time. Oh, heck, should I ask you about this? Just out of curiosity, are either of you guys, I don't know your respective backgrounds, are either of you either thinking of transferring to a 4 year or interested in AI as a just a general topic area?
Oh, I'm not sure yet.
Not sure. Okay. Well, no worries if you're not. But yeah, I'm asking because I'm part of I don't want to say committee, that sounds too official. Part of a gang. I'm gonna call us a gang. And gang, we're putting together a certificate, an AI certificate or a PCC. So you can get an associate's degree in AI. It's gonna be through the computer science department. So if either of you were interested in that, I could pick your brains about that. But we can talk about that later. All right, so agenda for today. So we're gonna finish up. So today we're gonna finish up module three. That's gonna be sort of a nice breaking point for us going into spring break. So again, module three is all about best practices, and so last week was a bit anticlimactic. It was all about stylistic standards in Python, which again, granted, there is utility in it, and granted, I appreciate it. And, I'm very grateful that there are people in this world who are passionate about those sorts of things because there's no question that it is a common good. But thank God I don't have to be one of those people. So I get to live in their, I get to reap the benefits that they sowed. But so we're going to talk about some other sort of best practice elements things here. And some of the things we've already talked about in to some degree or another, modules, exceptions and error handling, right? Those are all kind of ideas we've been playing around with in intro and even in this class a little bit. There is another topic, it's sort of a brand new topic, but it's going to be a topic that is going to be very relevant for us in the weeks ahead. And that is serialization. Just out of curiosity, either of you know what that is? I don't know that you would, but uh, I always feel like programming languages come up with these like fancy names for stuff that sounds so like official. Have any of you heard of serialization? No. All right, cool. Well, we'll talk about it. And it's cool because again, it does set up, I think, a number of really cool topics that we're going to begin to explore after the break. So, but yeah. So first modules. Let's see. So again, if there's one kind of theme in this class that we have been hitting again and again and again, it's the scalability of your program, right? As you go from programming sort of coding exercises to beginning to build outright programs and even applications that are, again, vastly larger and more complex in terms of scale. Um, how we make, how we make development at scale possible is that ongoing theme, right? And that goes all the way back to functional programming, right? Functional programming was kind of our first stab at that, breaking our code base from one long, undifferentiated sort of sequence of codes into segmented, self-contained blocks of code that I could then sort of define and then invoke when I wanted to, right? That was kind of our first idea behind that. Classes was sort of our next level of that, the idea that we could sort of encapsulate data and functionality in terms of attributes and methods within classes, and that was sort of our next stab at it. Well, modularity, right? I mean, that's kind of where we're going. Modules are sort of the next step at that because up until this point, pretty much everything we have done has been contained within one Python file, right? We've had typically our Python programmer.py, and we've just kind of run everything from there. But it sort of becomes obvious that at some point, you don't necessarily want these massively long, Python files, right? At some point, it sort of makes sense intuitively that we may want to break out our code and spread it across multiple different files. And that's obviously what modules give us, is the ability to segment not only within a file, Python script it, but across different files as well. And the idea being that sort of one of the, not just, again, not just Python, this is a pretty universal sort of code framework, but this idea that I can kind of segment my code base by functionality typically, and then into different files. And then I can sort of selectively import or bring in elements from one file into another as needed. Man, that's kind of the idea of modules. Um, Now we have sort of seen this before, and I'm going to come back to this if name equals main business, because we're going to talk about that a little bit more. But um, again, you guys should generally be sort of familiar with this. The other thing I'll point out is that we've sort of already been using modules and library. Libraries and modules are sort of the same idea. Libraries generally are more sort of extensive, but it's the same basic idea. Um, uh, every time we have made an import statement, we have, let's see, what have, in this class, we may have used things like OS, time, we used for like the ATM examples. We used, what else did we do? For some of the intro thing, we used math. Are there any other libraries that you guys remember importing and using in your respective Python journeys? Let me know in the chat if there are any. But right, but I mean, generally speaking, right, that you sort of have some exposure or some idea that you could sort of import and use sort of a whole array of tools that weren't necessarily kind of baked into Python. Um, and by the way, I think this is sort of another thing for us to note, which is, there's kind of, and this was a really kind of, I think, really cool and sort of elegant idea with libraries in general. So you have every time you sort of launch Python, right? Every time you sort of launch into Python, the Python program loads and it loads kind of everything around with it. So, it loads the overall program, the ability to sort of execute code, and then some associated sort of libraries as part of it. Um, but you have, actually, I should have talked about this. I realize I don't have formal slides for this, but let me talk about this. Um, but as part of that, over the years, as you're going to begin to work with Python, you are going to be using more and more libraries, and we're going to be using more and more libraries. And libraries are just, collections of code, collections of data. So you'll have libraries for dealing with data and parsing data frames. You'll have mathematical libraries. You'll have data visualization libraries, things to sort of plot data and do things like that. You'll have libraries for when we get into UI stuff. You'll have various libraries depending on what UI framework you're using. You'll have libraries to do um, networking and connectivity. I mean, basically any kind of functionality you use these days, you're going to be using libraries. And in fact, there's sort of a little bit of an irony with programming in general that oftentimes the more advanced the functionality, the less coding you actually have to do. It's a little bit counterintuitive, but the reason for that being that generally speaking, if you have sort of functionality that you want to sort of replicate, generally speaking, somebody in the Python sort of developer community has come before you, has sort of done the work of creating that, and then will sort of just publish that of it and make that available to you. And in fact, it's the whole idea, it really is kind of what makes one of the joys of working in Python as a programming language. I mean, there's all the virtues of Python as a language itself, but one of the really big unspoken benefits of, well, no, it's not unspoken, but I think maybe in this class, something that we haven't really articulated is the fact that you're not just tapping into a programming language, but you're tapping into an entire community. And that doesn't just mean support, that doesn't just mean documentation, that also means, you know, literally, you name it, somebody has come up with a library to do it in Python. And somebody has come up with a code base to do whatever that functionality is in Python. I mean, it's really just unparalleled, just how much you can do in Python. And that's, again, because the community is so vast and the number of people who are sort of actively developing and publishing open source sort of libraries is so vast that you can sort of do it. So over time, you are going to begin to install any number of libraries uh, into your sort of various frameworks. And in fact, so here, let me actually just show you. Okay, this is my color. So I can actually just kind of show you something here. Um, this is part of my reason. This is not for this class, but I can just show you because I do some pips for this. So that's what I'll show you. This, by the way, is some of the research experiments I'm doing for my PhD. I'm doing some time series analysis. We can talk a little bit about that, but so it's a lot of like data wrangling and things like that. But I'm getting into some time series stuff, and so to do that, um, let me go all the way down. There's a lot of stuff I'm doing here. Oh, I'm going to talk about this notebook actually. So this is kind of cool. Um, so as part of it, let's see, where do I do my pips? So as part of specifically doing time series, I don't know if you're familiar with time series. I'm throwing out that term. I don't know if you guys are familiar with it. Time series analysis is a particular type of modeling and simulation where you look at data chronologically. And the idea is, so generally speaking, there's sort of two way when we think about like machine learning and the idea of like machine learning, using machine learning models to predict certain things. There's generally sort of two ways of thinking about it. The first is um, statically. So, as an example, I give a machine learning classifier a photo of a dog. I'm like, is this a dog or a cat? Right? That's one way of doing it. Like, it looks at the data it's presented and it uses it to classify what it thinks it is. Time series uses historical chronological data to predict trends and predict next things. So typically through some kind of regressionary analysis, but also potentially classification analysis too. But the idea being you look at historical trends and then you say, okay, well, this is how the trend line has been moving. I'm going to predict this is what's going to happen tomorrow, tomorrow, tomorrow. Right? I'm going to predict this is what's going to happen to the stock market tomorrow. Right. That's time series. And so for time series, there's actually a really great library, Darts on. Let's see here. Time series made easy in Python, Darts. So you see here, so this is a great open source library that gives you tons of just like amazing tools for doing modeling and simulations, for doing visualizations. It's just fantastic. And you can sort of see here just all the different analytic models we can kind of run with it. Um, yeah, and this is the documentation for it. This is its GitHub page right here. So it's again, amazing library. I wanted to use it. So the first thing I want to do is I'm going to install all of these libraries into my environment. Um, and so when I'm doing that, let's see here, where's the thing? There's actually a specific command you run from terminal called pip. Pip stands for the Python installer program. It's basically what Python uses to manage libraries on your system. So where is my thing? So this is the consolidated thing. Okay, so this is my data frame. Did I get rid of my pip? I should have just commented it out. This is weird. Sorry, let me see here. Okay, so that's not it. Did I do it here? Did I get rid of that code? That's weird. I shouldn't have done that. Oh, pip install darts. Okay, there we go. Okay, so yeah, so the pip is again the Python installer program. Install is the keyword. You can do pip install. You can also do pip update to update library programs. In this case, it will take the Darts repository and will load it into my local device. So whether I'm running that on a cloud-based solution like Colab or I'm doing it locally on my desktop, it will install a copy of that library onto my drive. It makes that code base available to me. Okay, so that's generally the first sort of idea. And over time, your Python library, your sort of libraries of these different code bases will grow over time. Um, any questions on this first piece of it? Sort of how you can see, find, and install sort of custom libraries that are available. Okay, cool. No questions for. All right, awesome. But here comes an interesting question because then, over time, you sort of create this problem because you use Python for a few years on a number of different projects. You start installing a bunch of different libraries to the point where every time you run Python, you have so much just kind of dead weight in terms of your code base, right? Because every time you launch Python, you're launching so many different libraries as part of it. And so it becomes a real tax on your memory just to run Python. And so programming languages realized early on that they had to make this manageable, right? Because otherwise you would get into this scenario in which, again, you would have so much just dead weight code every time you tried to run Python. Because the reality is, 90% of the time going forward, I'm not going to be using darts, right? Darts is a very specific application that happens to be I'm doing time series, so now it makes sense. But the vast majority of the time, it's not. And so, when and how does it really make sense for me to always have darts in my memory when I'm running Python? So obviously not. And so because of that, we add a specific import statement. So you may have noticed like whenever we use a library, the first thing we do is we do an import statement. We say like import time, import OS, import pandas, import, those things. And the point of the import statement, so you can see here, I have a bunch of import statements here. Import pandas, import matplotlib, import stats models, right? Import all of those things. The idea being that I'm going to bring those out of storage, right? When I install something, it installs it into storage, in static storage, my hard drives. Bring it into my active memory while I'm running this session of Python because I want to actively use that particular library. And by the way, Python itself comes with a lot of libraries kind of pre-baked. Like for instance, OS is just a good example of this. So OS is a library that when you installed Python, it was one of the libraries that came with it. Now, every time you launch Python, it's not going to automatically run OS. Right? It's not going to load the OS library into your memory. But if you want it, you can do an import statement. You can say, "Hey, guys, right, load this into memory. I want to use it." So that's the idea of like an import statement. It's basically saying like, "I want to use this. This is part of what I want to sort of run." Um, but yeah, so that's kind of the two-step process that you have. You have typically libraries. Python itself comes pre-baked with a lot of libraries. Again, things like time, OS, IO. Some of these we're going to study in some future weeks. Or some other ones. Uh, I think stats is another one it comes pre-baked with. Math. Yeah, again, those are ones that like you didn't have to install, but those are just libraries that are sitting there ready to be used and ready for import statements. So So those are kind of the libraries. Now, in addition to that, you can also create your own. So the same framework, there's no magic to modules versus libraries. Arguably, libraries are just fairly big modules that have been published. But modules themselves kind of always exist. And all you really need to do to create a module is just save a program as a Python file, mymodule.py. All right, and so in this case, um, so this very basic example, I have a Python script. It has a very basic function, greeting, input name, print hello plus the name, right? Concatenated string, just print it. Great. That's my module.py file. Couldn't be simpler. Now, once I have that in another file, I can then do an import statement for it. Just like I can import a library, I can import a module. So I can say import my module, then it will reference all of those things. When I have that, I can then reference any potentially data, which we'll see in a moment, or methods directly from there. And you'll note that there's a very particular notation for it, which is module.method and then executable code. So in this case, it's saying reference the greeting function that's stored in my module. Okay, so again, so you can create any Python file and then just import that file into another file when you want to use it, and then reference anything in that original file in your new file. Now there is a note here, sort of an important thing here. For your import statement, you do have to make sure that the Python files are sort of co-located, or you have the right relative path. It becomes a little complicated. So generally speaking, just try to keep all your Python files in the same directory. You can work with them if they're in different directories, but it gets messy. And you want to make sure you have the correct paths and things like that. And so just generally speaking, if you can avoid it, avoid it. Just keep them in the same directory. It makes it a little easier. You may notice this as notation here. Import my module as MX. And be like, what is that about? So oftentimes when modules have longer, you notice how in order to reference it, I have to type my module.greeting, and that can be a little bit of a, just a lot to type out. And so oftentimes what happens is if we know we're going to be using a module very frequently, I can use a alias, a nickname, if you will, to basically reference it, to say I'm importing my module, but I want to reference it using this shorthand notation MX. And for instance, like you see this a lot, so I'll just pull back my other one. So for just, this is an example. If you do any data science, almost every time we're going to use Pandas. Pandas is Python data analysis. It's like the default library for doing any kind of tabular data. If you're working with any kind of tabular data, you're going to use Pandas. But it's kind of a pain in the butt always to write like pandas.readcsv, pandas.toDateTime. So you will almost always see import pandas as PD. And then you'll notice we just do a shorthand reference. We'll just do pd.readcsv as just kind of a shorthand for that. Just makes it a little easier for us. Um, let's see here. Yeah, oh yeah. Any questions on that? Okay. So I mentioned you can sort of do you can import anything from one file to another. And that's very true. You can, and specifically, you can also import data as well. And here's sort of an interesting thing. I mentioned this in passing last time. So you may remember last week I mentioned the fact that Python doesn't do constants. Do you guys remember what a constant is? So can't alter, correct. Data that once initialized cannot be altered, right? You cannot reassign um, a constant once it's been initialized and assigned, right? Other programming languages do it, as we mentioned last week. Python doesn't. Well, one way we can't exactly get there, but one way we can kind of approximate it is by storing data in one file as sort of a module and then importing it into another file. Because theoretically, where I cannot edit data in a different file from the original file. So just as an example here, so for instance, here in my little mymodule.py, in this case, I'm going to store a dictionary called person1. I can then import it, right? When I import my module, I can then reference it. I can say my module person1, and it can reference individual keys or the whole dictionary. But the point is, it's not just immutable, it's also unreassignable, right? This value, my module.person1 age, will always return 36 if I'm doing it from a separate file, right? So it kind of gives us an approximation a of a constant in Python. So store the data in one file, reference the data in another file, and it becomes not only immutable but unreassignable from there. So that's, I guess, kind of a little bit of a, I don't know if it's a trick, but it's just something to note. You may also note here that we can also do a from statement, which is, because oftentimes some of these libraries can be very, very large. Probably not a problem for your own little modules, but I mean, some of these modules are massive. Sorry, not so much a module at that point, but a library is so massive that, again, installing the entire importing, sorry, the entire library into your memory can actually sort of tax your thing. And so sometimes you'll just want to do a from statement that says, if I really only want to reference a particular function or a particular data set, rather than installing the entire, or rather than importing, sorry, the entire thing, I could just import a particular element from it, whether it is data or a function. And that's what you see here with this from statement. So from my module, import a particular thing. So in this case, I'm not importing the functions, I'm not importing anything else. I'm just importing this one dictionary. And then you'll note, just as an aside, when I import on a particular level, you'll notice I then am able to reference it directly. I don't have to do the my module dot person one there because I've specifically imported it. So it does get assigned, it gets bound to a local variable assignment as well. So that's kind of a little bit of a note there too. Um, so it's a little bit on modules. Any questions on that? All right, you guys feeling that all right? Okay, one final thing I'm going to mention, which is, do you guys remember this notation here? I'm going to try to just type it here. Do you remember this notation in the intro to Python thing where we said if name? No, don't. Okay, here, I'm going to do it. Guys, remember that particular line of code? You remember that how like for every lab we were doing after chapter 6, all the actual code was going to be in that? Do you guys remember that? Okay, I got one yeah. Anybody drawing a blank on this? Are you kind of remembering this a little bit? Okay, I'm just going to assume cool. People sort of remember it. Awesome. Did at the time, did anybody sort of walk you through what was going on with that statement? Like what that thing was doing? I will definitely explain. Here, no, I'm just going to tease you guys with that. I'm gonna move on. No, but obviously I'll explain that. So you may remember. So here I'm just gonna do like the worst. Here, let me actually just pull this up. Reconnect. Okay. So, all right. So we'd have like a. So you may remember we'd be like, okay, so def greeting, and I'm just gonna do print out of there. Okay, and then underneath it, I would have this if. Cool. Okay, yeah. Right. Yeah, programs would look like this. And so one thing you might remember, there was something different about how we were assessed after. So we got this notation starting in chapter 6, which not uncoincidentally was when we started doing functional programming. Um, you may remember that the way in which you were assessed and graded for your assignments changed. Do you guys remember that? Like up until that point, Zybooks was just would run your code and would compare it would sort of feed it a few examples and it would compare your outputs against, right, the expected outputs that it had. And if it matched, it would do it. But do you remember what changed starting in chapter 6, right? It still did that, by the way. You may remember it still did that, right? It still did the overall program, like does your overall program match the thing? But it did something else. And do you remember what that something else was? Okay, so no worries. So it also did what we called a unit test. So a unit test was it would not only test the overall program, but it would also test the individual function. You may remember this, like it would say, oh, your def greeting, is it outputting what we want to, right? It would see, is the overall program doing it, but it would also say, hey, are your functions doing what we think they will do? So they tested the individual functions as well. Um, yes, I don't know if you remember that or not. But yeah, that was kind of thing. So we introduced unit tests along with sort of the overall program outputs. And so part of how that worked was you sort of need to alter not just the program, but also the structure of the file itself. Because when you write Python scripts, Um, if you want to run the actual script, so there's sort of two ways you can sort of do it, right? I can run, if I have this saved as a script, if I run the script directly, let's say I have this as greeting.py, right? Theoretically, you can just kind of run whatever the program is. But I also can use it as a library, right? I can also use this as a module that someone else can import greeting and then say, hey, I want to reference this function here to my own library. And so by nesting it this way, this if name equals main, it says, okay, how are people accessing this file? Because there's one or two ways in which they're doing it. Either they're doing it as like an import statement, where they're importing this into something else and then potentially to use this helper function greeting, or they're executing, again, let's just say this file name is here. I'm just going to put it on screen and make it clear. So let's just say we save this as, let me change this to, okay, greet program.py. Okay, so that's the thing. So one of two things are happening. Either I'm doing an import greet program.py in my little thing, and then I'm going to have like a little. So let's say this program is, let's just call it main.py. Right. So first I do the import statement, and I'll just do like greet. Yeah, thank you. And then I reference it in this main thing. Or in terminal, I'm just going to run Python greet program.py. And it tells the Python program, hey, execute this script directly. And so this if name equals main basically says, hey, if the Python interpreter is executing this at the sort of terminal level, then name becomes paired with main and basically says, run this code here. So run whatever this program is, you're running this like a program. Otherwise, if whatever the main program is that's running, let's say it's this main.py, then we're not running this. So we don't run this code. We just reference this code as part of the main code that's running. So that's what this whole if name equals main thing business was. It gave us the ability both to create sort of program elements that served as modules. So again, like this greeting, right? The way in which Zybooks was able to extract greeting was it basically did these import statements. It imported the function and tested it, and that's how it got the result. But it also ran your overall program directly and looked at the outputs, and that's where this if name equals main came into play. So does that make sense? Okay, awesome. All right. Let's see here. Let me think about this. Okay, so that is modules. So okay, anything else we want to talk about with modules? All right. So I want to actually skip things up a little bit. I want to suggest, I don't know how you guys feel about this, but I want to actually jump topics and talk about error handling now, just because that's something you theoretically already dealt with and you've already worked with before. So you should be relatively familiar with it. It should serve more as like a review for you guys. And then we take a break. And when we come back from the break, we talk about serialization and take that through to the end of the class. Does that sound okay? If we're importing that. Oh, Munina, that is a great question. Okay, so for those of you who are watching the recordings, there's a question. If it says if you're importing a library on Colab, do you have to save the Python file in our Google Drive? Okay, so there's it's an interesting question. There's a lot kind of going on there. Um, so Colab is kind of an interesting idea in that it's like it's a hybrid of a document, right? There's sort of a static element to this where it's kind of a document that you can access and read, but it also connects to a virtual PC. And you use that to actually sort of run and execute the code. So it's kind of both. So, to your specific question, So when you sort of disconnect, right, when you leave Colab, Google will save the document element of this. So all the individual code, all these sorts of things, this will all be saved. And you can come back, you can reload it, things like that. But the actual sort of virtual desktop, and essentially the cloud compute instance that you were running with this, and any sort of associated files, any sort of libraries, things like that, that gets wiped every time you go away. And it's actually an interesting topic because that is going to lead into our serialization discussion because we're going to start to think about sort of object permanence in Python because that's a really interesting question, right? Because right now, the moment a Python program exits, all the data that was in memory goes away. And so the same thing will happen here too. So like if I walk away from Python, from a Colab notebook, and then I load a new notebook, I load the notebook again and I connect it to my cloud computer instance, essentially what happens is it loads a default set of whatever sort of basic Python libraries come with it, um, are loaded with it. It basically kind of Colab includes its own suite of libraries and that gets included. But as an example, um, where is my other one? This one. So darts is an example of something that isn't included in Colab. Where is it? No, darts. It is right here. So right now, sort of after I ran this pip install command, darts was installed into my cloud compute thing. But when I disconnect from Colab and I relaunch this again next time, darts will no longer be there because again, it'll launch a brand new cloud compute instance with just default parameters. So I would have to run this again to reinstall darts into that cloud compute instance to then kind of be able to run any of the associated darts libraries. So does that answer your question? Now, but again, one thing to clarify with that too is that that is also a unique function of Colab, right? Because Colab is a cloud computer thing, and the whole idea is, right, Google is not going to save a bunch of just cloud compute instances for you guys. The whole idea is that you basically kind of use it on demand. And so that's why every time you have to install it. Now, if you're working on your desktop, you just have to install this once because once Darts is installed onto your device, then it's in your library. Then you don't have to install it every time. It's there. It's in your static storage. All you need to then do is to import it, right? All you need to do now is import, let's say, time series or whatever you're working with. Um, because that way you just bring it into memory every time you're working on it in Python. But that's a little bit of a difference between, again, a cloud compute based platform and let's say a desktop. So cool. Yeah. So great question. Any other questions on this? All right. You guys want to tackle error handling now? And then take a break? Or you want to take a break early and then do error handling? What would you guys prefer? Okay, gotta vote for error handling first. All right, let's knock it out, shall we? Okay, two votes for error handling. Cool. All right, we are of a like mind with this. So, and just out of curiosity, how much do you guys recall of error handling? That was chapter 11 in your intro course. You guys remember the whole try accept idea? Wrong one. This one. I got at least one of you. Okay, cool. All right. So, basic idea here was that no matter how robust you make your code, people always find ways to break it, and that's sort of inevitable. And you sort of one of the things that we try to do is to think about how to make it more robust to it. And, you do a lot of like input validations and things like that. And again, just try to kind of reduce your points of failure. But again, inevitably it'll happen. And so, are there ways that the program itself can handle errors? And of course, we do have that right as a code block, and that's the try except code block. So whatever the code is that you want the number to, that you want the program to execute, you embed it within a try. And right, typical kind of branching, right? So you try it, and if it works, great, right? Just kind of continue on. But if it raises an error, rather than crash your overall computer, you sort of uh, instead throw it a whatever the accept is, whatever happens within the accept block, right? Kind of standard branching, but the idea is it's sort of tailored to exceptions. So like classic example of this is, say we want to do uh, a really basic thing. Okay, so I'm going to take in an input. I'm going to say number equals int input. I'm going to say uh, so print. Um, let's say 10 divided by, okay, really, really basic program. Um, it works. If I do something like 5, that works. Everything's good. But what if I do instead of, again, silly human, I type out 5? Well, boom. That throws a value error. Um, anyone remember what a value error is? So in fact, everyone remember the big error types. In fact, do you guys want to throw up an error type in the chat? Something you remember? So I think so while you're doing that, I think the two so value errors and type errors are the two that get, I think, confused the most. So I don't know if do you guys know the difference between a type error versus a value error? So a type error arises when I try to do something with a data type that is not allowed. So just as an example, if I try to, for instance, concatenate a a string with a integer, right? That's a type error because I cannot concatenate an integer. That just isn't allowed, right? So it's interesting. The plus, so here's kind of an interesting sort of thing of polymorphism. So remember, polymorphism was this idea that like the same operator, the same function, depending on its context, can mean two different things. So here's kind of an interesting thing. So let's do sort of an example of this. So if I do 1 plus 1, so this will throw a type error because it'll say, hey, it can only concatenate strings to strings, right? It cannot concatenate an int to a string, right? Okay, kind of makes sense. Again, that's a type error. I did the wrong type of thing. Now, the reason this is interesting from a polymorphic perspective is check out what happens if I reverse this. I do int first, right? So in this case, check this out. I'm still going to get a type error, but the interesting thing is it says it gives me a different error message. It says unsupported operand types for plus int and string. Because remember, Python reads left to right. And so the first time I ran it, when it was string to int, it said, okay, string plus, oh, okay, that's a concatenation thing, right? Plus in this case is a concatenator. And oh, nuts, you're trying to concatenate a string with something that isn't a string. So that doesn't work, right? But this time it looked at it and said, okay, integer plus, oh, this is a numeric operand, but plus a string. I'm like, well, I can't do that, right? So that's a type error. So type error says basically I plugged in the wrong data type for an operation. In this case, again, it doesn't handle strings. Value error says I passed in the right data type, but the specific value that I passed in doesn't work for the particular function. And so in this case, the reason that this tripped, so you may remember here, right, inputting a number, I typed out 5. So in this case, what tripped it was this int function, right? Int function obviously converts a string into an integer. Well, it only does that for numeric characters. So even though I technically typed out a number, five is a number, but because I used um, alpha numeric characters, or I used alphabetical word characters, the int function didn't know how to do it. So it's a string, right? It takes strings, but it's the difference between that string, which is numeric characters, versus that string, which is, again, alphabetical characters. So that's a value error. So it raised the value and says, hey, I can't really do that, right? Okay, so again, so that's a value error. Others I can't remember on top of my head. Yep, syntax error, perfect, index error. Yeah, those are good ones, you know. Yeah, so syntax error is typically typos, right? So, you know, if I do 5 plus, right? There's syntax error. Uh-oh, right? A typo there. I put in a extra colon there. So that's a typo. Another very common error is a name error. Does anyone remember what a name error is? Perfect. Munina, exactly right. So identifier hasn't been defined. Exactly right. So in this case, and that's often typically a typo. Um, so it's kind of related to a syntax error, but like oftentimes, like I may have a, so I may have a right. So number, or in this case, number is 5. I might just do like that and give me a name error. And so I'll say again, number is not defined, name error, because I referenced a variable that hasn't been defined. But in that case, like 9 times out of 10, it's a typo, but it's a very specific typo, right? A you mistyped a function. Okay, so that's another really good one. Una also mentioned index errors. Yeah, that's a huge one. Index out of bounds error, right? You know, you have a list with 4 items, and so you do index position 4. Well, why is that a problem? Well, that's a problem because you may remember uh, Python being zero indexed. So if it has 4 elements within it, then it's going to be index positions 0, 1, 2, and 3. So if you actually do index position 4, it's going to give you an index out of bounds error saying, right, that index position doesn't exist. So that's another great one. Another really common one that we get a lot is indentation errors, right? If there's an accidental indentation, if things aren't kind of aligned, right? Particularly, I think when we were starting out, we were doing like a lot of branching early on. We probably got a lot of those indent, right? Unexpected indent errors. That was another really common one. Um, Let me think. Any other ones you guys can think of off the top of your head? I think those are the heavy hitters. I think those are the primary ones. Yeah, I think that's it. All right. So anyways, yeah, so we have all these errors. So again, so this is obviously going to work sometimes, but not always. So I'm going to put this in a try block. Try, and then a little accept. Right, and I can just print, yeah, print that as not a number. So now if I run this, right, same idea. So now if I do this properly, so I do 10, it works, right? The try block works. Ran my little branch, try worked. If I do 10, go down the accept, right? That's not a number. So kind of a lot nicer than getting this whole like your program crashed business. Although one of the things we'll talk about is there's sort of an important, I think, thing to note about exceptions. Like, yes, it does provide a graceful exit if you want it for programs, right? It doesn't just give you this nasty little thing, but gives you sort of a nice things. But we're going to talk about sort of, I think its actual main function is kind of to correct the program and continue it. Can we accept specific errors, Chloe? Yes, I'm so glad you asked. That is exactly what we're going to do right now. So you can also, this thing about the branching, you can also branch on very specific errors. And so just to use this example here, so we already saw the value error, right? So I can do except value error. And that way, if you raise a specific value error, it will do it. But there's an interesting thing that happens with that, right? When I did the except statement, it basically initially says if you throw up any error, it'll work. But here's an interesting thing. So let's try this right now. So again, right, if I do it correctly, it works. If I do that way, it'll throw up this non-error. But I can actually trip another error for this. Anyone know what other error I can trip for this code? So obviously I saw a value error here. Is there another thing I can input here that'll actually trip a different error? Zero. Chloe, you were absolutely right. Zero division error. Right? If I try to divide by zero, I'll get a zero division error, right? It's going to say, again, right? Not the most useful thing, but division by zero. So the interesting thing here is if I get rid of the value error and I run this, then it'll throw that this is not a number for anything. But the moment I do value error, it will only, right? If you think about like the branching, I'll do the try, and then if it trips a value error, go down there. But if it trips any other kind of error and you haven't explicitly defined it, it will not go down there. Now, having said that, I could just do that, right? I could also do except. Yep, zero division error. Cool. Thank you. And that way, if I do this, it'll go down that branch instead. So yes, 100% we can trigger on specific errors as well. One other thing that's really cool, and is you can also sort of you can also raise errors even in the event that the program itself is not going to crash. So this is kind of a really interesting idea because there are times when the user is going to input things that aren't technically wrong from a Python perspective, right? It's not something that's going to crash your program, but it's wrong from a program, how do I say it? From the specific use case of the program. And I think this example here, I think is a great one, which is why I just kind of copied this wholesale here, which is, so here you're going to see here, this is basically code to calculate your BMI. So you have the user take in, let's see here. Yeah. So you have the user take in weight and you have the user take in height, right? So the user has to input their weight and has to input their height. Okay. And those are converted to integers. Now you can obviously imagine, we already saw this, right? If somebody doesn't put in stuff that will convert into integer, it'll raise a value error. But you could see a scenario, for instance, where a user puts in a negative number or puts in zero, right? Their weight is zero. Now, theoretically, as far as Python is concerned, that's perfectly fine, right? Because I can take zero as a character and convert it into an integer. And I can convert that integer into the formula here and I can get a mathematical result, right? There's nothing here that's going to trigger an error by that. But from a program perspective, that's clearly wrong, right? I cannot have, my BMI calculation does not work if somebody inputs zero or somebody inputs a negative number for that. And so in this case, I can use the raise keyword to actually trigger an error when the program itself otherwise wouldn't have triggered an error automatically. And so I can kind of co-opt this sort of try except system to basically say, I'm going to make my own little triggers for errors that, again, Python itself is okay with, but my program specifically is not. And again, you can sort of see two examples here, right? If my weight is less than 0 pounds or my height is less than or equal to 0 pounds, then that's not going to work. Um, so yeah. Out of curiosity, can anybody think about why um, this code specifically is less than for zero, but a less than or equal to for height? Anybody think about why there's that distinction? Because I mean, right, both of those doesn't make sense, right? You can't really have a weight of zero or a height of zero either, but only one of those technically will raise the error, right? Weight will not, if I put down exactly zero, technically I won't trip a value error for it. Anybody can think of why I have that distinction between weight and height here? So I'll give you a hint. Look a couple lines below it. Look at the actual BMI formula. Here, I'll make that a little bigger. So, all right, let me make it more specifically. If I actually, perfect, Chloe, you got it. Yep. Division by zero. Exactly right. So I said before, if I put in zero, it's technically not going to raise an error by Python itself, but that's not actually true with height because look at the formula here, right? In this case, it's weight times 703 divided by height squared. If height is zero, then that's going to be a zero division error. So it actually will trip an actual error in my code. So that's why there's that little notation there where it's a less than or equal to versus just a less than for weight. So I guess a minor thing there. But again, so this is kind of a cool thing, right? So I have this specific thing that says if this thing happens, raise this error. I nest this entire thing within a try block. And then again, within my except, I can say, hey, if an except, if a value error gets captured, run that. One other thing you might note here is that you may notice this as notation here. You may see here this raise variable as except. So one thing to note here is that you notice that there was a specific sort of text with the error. And so you can actually capture that and print that out. And here, let me just kind of show you that. So, um, so here, so watch, if I do this, you'll remember that's the actual line for that. Just print this too. So you see, remember that was the actual text that was thrown up when it crashed. So I can grab that using this as statement and then pass it through to the except block. So yes, that's kind of another thing to note. I do have this notation here. Oftentimes too, you can sort of nest these sort of raise things within functions. And again, one important thing to note is that these still get executed within a try block, right? The error doesn't get raised unless it is within a try block, but it can be really helpful to sort of nest these within helper functions because that can sort of help you sort of source where particular errors are coming from. But again, I think one important thing to note again is that you can't just have a raise statement. You have to have a raise statement that is then nested within a try except thing. And so again, this is an example where we put the raises. It's the same basic code, but in one case, the raise was directly in the try block, right? You just had sort of the raw source code here. In another, we nested it within a series of helper functions. And again, then we invoke those functions in the try block. And again, that can just be helpful because that does help to sort of specify where those errors are coming from. All right. Any questions on that? So, final thing I want to mention is the finally block. Actually, no, there's two things I want to mention. Sorry. This is gonna be the first one. Ironically, finally is not the final block. But um, I mentioned that there's parallels between right if else type deals. And one big difference is that if statements don't require an else, right? We've talked about that before. You can have an if, and then if it just doesn't, if you don't do anything, nothing happens. Try, however, needs an outlet, right? If the try fails, if an exception is raised, you need to have an outlet. The outlet can either be an except or it can be a finally block. And a finally block basically says that no matter what happens, I will always run this particular code. Basically, it's kind of I almost think of it's like a yeet type thing. It's like as I'm crashing, I'm like, yeet, you're jumping off the window. I'm still, no matter what, before I allow my program to crash, I'm going to do this finally. And I'm going to show you an example of this finally. Yeah, print this is always executed. Okay, so let's show an example of this. So this works well, right? This is always executed. If I raise a value error, uh, it it goes down the 6 step block, but it also throws me, right? It first throws this, but then it also executes this. Finally, now you'll notice here I got rid of the zero division block, so it's going to crash. But you'll notice before it crashed, even though theoretically it crashed here, it still first executed this. This is always executed and then it crashed. So point is, finally, basically will always run regardless of whether or not your try or accept or whatever fails. So that's a finally. So any questions on the finally? And again, remember, a try needs either an accept and or a finally. You can never just have a try block. So any questions on that? So the final thing I do want to say on this subject before I move off it is when we talk about try accepts, a lot of the times, again, we think about these as kind of like like I've said, sort of a graceful exit. It's rather than getting this harsh, like, your program crashed. We get some kind of nice little status. It looks like, okay, it's whatever. But the thing I want to emphasize with this is the majority of the time when you will use try accept blocks, it's not the graceful exit use. It instead is this idea of saying, okay, well, I want to sort of keep that if the train gets knocked off the track, right? If it gets derailed a little bit, I want to force the train back on the track so that the overall program can keep running, even if my idiot user has kind of created a problem. And so let's do an example of this. So let me just grab this try block. I'll modify it. Okay. So I have my little try block here. I'm just going to do accept. I'm going to do anything with it. But so normally, let me think what I want to do. So normally what I say, okay, so here. So let me get out of the accept block first, and I'm going to show you this. I'm going to say print, here, number equals, so let me change this to be print, and I'm going to say result equals 10 divided by number, print result. Okay, and for this one, I'm just going to say pass for the moment. So let me run this. So right now, again, I'm going to do like 10. So that worked. If I do, okay. Wait, what? What? Why did it throw one? That shouldn't have worked. Hang on. Is it doing something I don't think it should be doing? Oh, I know what it did. Okay. Okay, because it crashed on this. Okay. So this is an interesting sort of thing. It actually is crashing on this number, but result is still there. So it actually is still printing result because that's what the pass is giving me. Interesting. Okay, that was unexpected behavior. But here's what I want to show you with this. What I want to do is instead, I'm going to hard code a fix. I'm going to print you entered the wrong number, dummy. Do a new line. Setting the for two, two. And then I'm going to say, so now let me try this again. So again, so if this works properly, right? 10 divided by 2 is this. But if this doesn't work, if I do Larg. You entered the wrong number, dummy, setting the number to 1 and then getting this result. So the point is what I'm sort of doing here is I'm kind of hard coding a fix to my code. I'm basically saying, okay, user, you made a mistake, but I want the overall program to run and to continue to run to conclusion. So I'm going to hard code a solution, right? I'm going to just accept the fact, here, actually, let me make it even more explicit. Because I can move that result out of there. I don't need the result to be in the block. Yeah, so there. Because So here, I'm going to try, user, I'm going to try to take your input. If it works, great. Then I'm going to divide it by this and I'm going to get a result. Actually, no, that's not going to work because the zero result, actually, that'll work for the value error. That won't work for the zero division error. Hey, bud. Hey, kid. Oh, you're here. Oh, I'm so excited.
Why are they coming out for me?
They came out to say hello. All the little animals are here. Okay. So folks, let me finish up this point and then we're actually perfect timing to take a break anyway. But yeah, so actually, sorry. So this will capture the value error, right? Because the value error is tripped on this line of
I
code.
was so mad. Da, da,
When am I going to show you what, honey?
da, da.
When am I going to show you? Here, there's you in the corner. You see that? There you are.
Da, da.
Yes, buddy. Okay, we're just going to finish up this idea with them, and then I'm going to take a break. I'm going to come down and read to you, okay? Can I read you a good night story?
Back.
Mm.
This is the day I made a holy one that you could never make. And you think I made it with Mama
Yeah.
because it is so big, but turns I made it all by myself.
Oh my God. Oh my God. Okay, I can't wait to see it. Okay, okay. I'm going to finish this up, and then you're going to show me, okay, buddy? Okay. Okay. So yeah, so sorry. So this actually, so if I tripped a zero division error, then actually my program overall would fail because again, that would be tripped here. But the point is for a value error, the idea here is that I'm going to try this, and if it works, great, move on to the code. If it doesn't, I'm going to then trick this and say, right, in this case, I'm going to force correct your thing so I can run the overall program. So again, most of the time when we do try accept blocks, it's again with this idea. It's not the idea of the graceful exit. It's the idea of saying, I'm just going to hard code a fix for you because you, the user, are doing an error, but I don't want you to crash my overall program. I want to keep the overall program functional. So I'm going to do something again that kind of hard codes a solution. So again, that is the majority of the time when you are using a try accept block, that's where you use it, and that's when it's most useful. So, and you typically do it around inputs because obviously inputs are precisely where the user has the ability to modify your program and actually crash it, right? So, okay, hang on, buddy, 30 seconds. All right,
I'm gonna
folks.
prepare your present.
Oh, thanks, bud.
Yes.
Oh, thank you, bud. Any questions, guys? Yes, buddy, that's beautiful. No questions. All right, well, that segment ran a little long. Yeah. Oh, I'm going to tell you right now. Okay.
No, wait, let you tell them to me.
You want me to introduce you to them? Oh, guys. Okay, sorry, guys. So, okay, we're gonna take a break now. But guys, Savannah wants to wish you all a good night. Savannah, you want to say good night to everybody?
Good night. Present for you guys to see.
Is that a present for them?
Is this a good present?
I think that's a beautiful present, buddy. It's a sparkly rock.
It's a sparkly rock with a bottle cap. This is a bottle cap with a sparkly rock on the bottle cap.
Dude, that is just the most epic present ever. Oh, and they're even saying they love rocks. So they're excited. Buddy, let's let them take a break. Okay, folks, let's reconvene in a little, let's say 10 minutes, give or take. May take an little extra minute or two to get her down. Um, and then so yes, let's say roughly 50 56. Let's reconvene. All right, and we'll talk about our last topic of the night. So okay, let me pause. All right, how's everybody doing? Okay. Any questions on error handling? Questions on modules, libraries? So far, so good? All right. Awesome. Okay, so let's talk about last thing I want to talk about serialization. Okay, so um okay, up until this point, right, we have been sort of developing programs in Python. And as part of that, we may have had a little bit of um, sort of an intuition for the fact that there was an intrinsic limitation with Python, which is that, Python, while the program is actively running, it occupies memory. And then, any data that is created, that is updated, that's modified, exists in the lifespan of the program. But the moment that program ends, the any sort of associated work, any sort of documentation disappears, right? And we sort of saw that a little bit with the ATM thing. It was sort of uh, good example of that, right? We had the ATM program that would here, I'll even just why don't I just show you guys? You may remember this. Let's CD over to I think it's in downloads. I think let's see ATM. Nope. Okay. It's in documents. Okay. There we go. Okay. So, right. So you may remember I have my little Python thing. I'm going to create a thing, new account holders, and it's going to be me. Uh, digits flat. Okay. I'm going to deposit $100. Great. My balance is 100. Okay. Now, if I try to access it while I'm running the program, great. I'm going to access it. Okay. Welcome back. Account holder is Lionel. Balance is 100. Okay. This looks good. But then what happens when I exit? Okay. Now, when I exit, if I restart it, say, okay, no problem. I'm just going to try to log in, right? I'm going to access 2, 3, 4, invalid PIN, goodbye. Oh no, what happened, right? And what happened was everything that I created, the moment that program halted um, and Python exited, everything that was in memory disappeared, right? And so clearly that's not it's not got great longevity, right? If your whole life cycle is that. And so one of the things that we are going to begin to migrate into, and this is a topic that we are just going to begin to touch on tonight, but as we begin to think of self-sustaining applications, applications that um, are fully functional, a key functional element is the ability to retain and store work that's being done, right, in the course of the program. And that's ultimately sort of part of as we build out towards a full stack capability, right? Full stack, if you guys are familiar with that framing and that phraseology, full stack just means essentially front end to back end, right? Everything from front end being the user interface, right? Sort of a nice graphical user interface. Users can sort of interact with the program to the middleware. And Python typically is sort of the middleware. It sort of typically is an interface between a UI and a backend, and the backend being the permanent data storage, the storage that exists and persists after not only the program itself exits, but even when the computer, the overall hardware shuts down, right? I mean, imagine how useful your computer would be if every time you turned it off, all of your data just got erased. That clearly wouldn't be great. So um, part of kind of building that full stack capability is the ability sort of to ultimately sort of write and store the results in a format like that. And so again, this is something we're going to sort of begin to explore tonight, but it's going to be something that we're going to continue to explore because, by the way, writing and storing is a big part of it, but also equally important, if not maybe in some ways more important, particularly these days with cloud computing, is the ability to write and exchange information across different programs. So in either case, we need to have a way of taking data that is stored inside a Python program and essentially sort of packaging it in a way to then store it or ultimately transmit it outside of the sort of the Python, the little walled garden that is our Python program. And that's really what data serialization is. Again, it's sort of a way of converting, I have the formal data definition here. It's a way, let me move this out of the way. It's a way of converting structured data. Again, when we talk about structured data, we're talking about, things like lists, dictionaries, things like that, into a format that allows for external sharing or the storage of data. And critically, it's also a form that allows the recovery of data in its original structure, right? If we sort of serialize and export data, we want to be able to read it in again, and sort of establish it in the same data format. So there's also a notation here that in some cases, we also may want to minimize the data's size. So you may be familiar with like compressing files. So sometimes we want to do that as well, right? So serialization can also serve as a data compression mechanism too. So that's the basic idea of serialization. Now, the first thing to note is we need to sort of think about how data is structured. And generally, we need to think about both flat data and nested data. So flat data is data that exists on sort of a single dimensional space. Easy example of this might be like a really basic list. So here, let me just here do a very simple thing here. I'm just going to just call it names equals. I'm going to make a list. I hope you guys don't mind. I'm just going to use you all. So, Una, Nina, uh, Berlin, and forgive me, Chloe. I'm just going to do 1E. All right. So this is data that's stored that's sort of, again, we call it consider sort of flat data. Nested data is data that sort of has um, fields and subfields and sort of things like that, right? So, I mean, if you think about like dictionaries and dictionaries with nested data, here, heck, let me even just show you. I mean, I'm going to talk a little bit more about this in a moment, but like, here's an example of nested data, right? And I'm deliberately just going to throw this up on screen and not spend time on it because I actually want to come back to this in a moment. But when I talk about nested data, this is what I mean. Um, so for flat data, one of the easiest ways to kind of serialize and export flat data is as a CSV file. Now, are you guys familiar with CSV? Okay, I'm seeing a yes, yes. Okay, a handful of yeses. Okay. Seems like in general, yes, and not surprising. CSV is just simply stands for comma separated values, right? And it's probably the easiest way of representing tabular data in Python, or no, sorry, not in Python, in just any data serialization mechanism. And so we have the ability to sort of very easily write and read in CSV files. There are multiple libraries to do so. If you're working in data science, you'll typically use the pandas data frame. We can also just use the CSV library, which is just a default um, library. You don't need to even do an import statement. I think it's just part of base Python. Oh no, sorry, I'm wrong. You do need to do an import statement. So I do need to do an import CSV, but I don't need to install it. It sort of comes in with Python. Um, and then you may remember from chapter 12, we had that whole like with open. Do you guys remember this? You had the open thing and you could sort of do it and I can define a thing here. So I could say names.csv and it's going to be, you may remember this from chapter 12. We can say either a read or a write. So I'm going to do a write. Um, and then specifically here, by the way, um, oh, okay. Thank you. Let's see. Yeah, that's pretty much what I wanted. Okay, cool. All right, that's that's kind of what I wanted. Okay, that's helpful. Um, CSV also, so you may remember that from just like with open when we were doing like text files or anything like that. So you open it, it's in write mechanism. There's a new line parameter. A new line basically says, how do you sort of indicate the presence of new line? And so in this case, new line is just going to be a space there. It's going to indicate a new line. So a CSV file, you create a specific writer instance for it. You're going to say it's going to be CSV writer, the CSV file. Um, and then I'm going to write a specific row. So now, and that row is going to be names. So I'm going to do that right here. I'm going to run this. And now if I go back to my files, you'll notice here, I now have a new CSV file in my little Colab thing. If I open this, you're going to see here, it actually includes the lines that I did. And in fact, by the way, I can also write more if I wanted to. I could even do, let's see here. I can also do ooh, no, keep that in mind. I'll do a writer. Oh, okay, cool. Thank you. You actually write multiple rows there. Now, if I load this again, you'll see here. Oh, why? Oh no, did I? Oh yes, sorry. Okay, fair enough. Yep, that would create an issue. Oh, I had a little dimensionality issue. Okay, there you go. So you can see here, it defaulted to showing one of these as header, but now you can see here I wrote these two rows as my little CSV file. Okay, so that's kind of how I write it, how I export it. I have these lists and I can write them to CSV files. I can just as easily read them, right? Same basic idea. So now I'm going to create, in this case, I'm just going to create a list of lists. I'm going to say data equals, it's going to be a blank list. And I'm going to say with open. And then, oh yeah, look at that. Okay. Yeah, that's good job, Google. That's actually what I wanted to do. Names.csv. And again, this time we're going to do it in R mode. We're going to be doing read mode. I'm just going to say, so I can just do it as anything, as file. And so I'm going to say, now I'm going to define a reader instance. So reader equals CSV dot reader file. So now I read in, and now I'm going to loop each row within the reader. So I'm going to say for row in reader, yep, data.append row. So I'm going to add that row, and you're going to see it's going to be a list. It's going to be a list of lists, basically, is what's going to produce. So let's run this, and then let's take a look at data. You're going to see here, it created a data structure in which, right, it's the first instance of it is a list. And if I wanted to grab the first name of the first list, gives me, get out of there. And if I want to grab the first letter of the first name of the first list, I can just do that. Okay, right? So it gives me, again, it's a way of object permanence. It's a way of bringing into importing and exporting data. And that's as a CSV file. Questions on CSV files? So CSV files are really, really useful, particularly if you're dealing with data. You're dealing with tabular data. Obviously, CSV is kind of the default thing. But I would actually say, for the most part, a more useful data serialization method is JSON. Now I'm asking again, how many of you have heard of or are familiar with JSON? All right, so I got at least one heard of it. So JSON is that, along with XML, are pretty much the standard ways for for um, do sort of doing data interchange on the web. Um, and the idea here is it's a really, really standardized, really simplified mechanism for storing sort of complex hierarchical data structures. Um, and and what's interesting, and even though it says JavaScript, it stands for JavaScript Object Notation. Um, It's language independent. So we use it in Python. We obviously use it in JavaScript. You can pretty much use it in any program function. It works. And what's interesting about it, so here I have an example here of a JSON file. I forget if this is, I forget if I use this as an example or if this is an assignment, but either way, we're just going to kind of run with this. But here's an example of nested data. And if you look at this, right, this is a JSON file. But if you think about this not as a JSON file, but as a Python data structure, you can sort of begin to see what I mean. Like if you see it overall, it's a list, right? It's a list of, in this case, people, and each item within the list is a dictionary. So you can see here, right? It's a list composed of, it looks like 3 people, and each entry in that list is a dictionary. The dictionary has a series of key entries, key values, right? You have a name, age, email. Address itself is its own dictionary within a dictionary. Right, so address is a dictionary. You can see here it has other specific key value pairs, so street, city, state, zip code. And then interesting enough, we also have interests, which is a key, but the value with it is a list. Right. So again, this is a JSON file, but you can very easily see how this is a nested Python data structure as well. Well, we have the ability to take this static text file here and turn it into a dynamic data file that we can then do stuff with. And similar basic notation here. So I'm going to just drop this in. Let's see here. I'm going to, I think it's people.json. Let's see. Yeah. Now I'm going to upload this into my directory here, and then I'm going to say, okay, so now there's another library I'm going to do. It's going to be the JSON file. So I'm going to import JSON, and then similar basic structure here. Yeah, I'm going to read this. I think I'm going to read this in first. So no, so don't do what it wants me to do. In this case, Google, you were doing so well, but you got this wrong. With open, names dot JSON. Now we're gonna read. We want to read it as file. And then, by the way, for JSON, I'm just going to tell you right now, the two sort of actions are load and dump. So load is what you use to load it and read it in. So the JSON load file kind of reads it in and converts it to a Python data structure. The dump does the opposite. The dump will take a Python data structure and convert it into JSON. All right. So we're going to do obviously the load right now. So we're going to say data equals, yep, JSON.load file. It's that easy. Oh, maybe it's not that easy. No such file as directory. Oh, people.json. Yeah, fair enough. Okay. Now if I go back here, I'm going to see here I have data, and indeed data is a list with 3 items. So over here, if we see, again, if we print data, right, that looks familiar to us, but the difference this time is if I index and say, well, give me the first one, you'll see here again, that's a dictionary, right? Dictionary with that thing. And if I say, oh, okay, well, I want, sorry, key is going to be, say, interests. Well, it's going to be that. It's going to be a list. And if I grab the, let's say, the second one of interest, oh, second one of interests gives me hiking. And by the way, now that this is a immutable data structure, I can turn that around. I can say, well, he doesn't actually like hiking. Let's say he likes, what does he like? Scuba diving. Scuba diving. Okay, so now if I look at, let me just go back to data 0. So John Doe, we're going to see here he likes reading and scuba diving and cooking. So you can do all the mutability and all the data edits that you wanted to um, using that. And by the way, now that we have done this, I can then store those results. I can then say, okay, well, I want to store those results. I'm going to go back here. So now I'm going to go back to open, with, yep, this time. Okay, this time you got it right. So this time instead of opening as a read, I open it as a write. And this time, instead of a load, I do a dump. So I'm going to dump my data into the file. Around that. And now if I look at the people.json, if I open this here, you're going to see here John Doe, and his interests are scuba diving. And now we've stored this as a static JSON file. So again, very typically, right, if you were working with programs, and again, you want some object permanence to it. Great question, Chloe. So, great question. It's not on Google Drive, and that's actually an important thing to note. It's in this session of Google, it's in this cloud compute session. But yeah, if I exit out of this, this is gone. If you want it to be in Google, so this is actually a really important thing. So I can show you here. You actually runtime. Okay, fine, close. You can connect it to Google Drive, but you have to do something. So you have to do. So here, let me show you. There's a specific program. So like in this case, um, from Google Colab, you import a specific thing, drive, and then I mount the drive. And so basically, I have to connect, in addition to connecting to the cloud compute instance, I have to mount my own Google Drive. So it's basically, you can almost think of it as like plugging in my Google kind of hard drive into this. And so like in this instance, so you'll see like I have a bunch of like raw CSV files. So I had to mount my drive. And then when I had it, I could then read in all the results. Um, and then once I had that, in the end, so let's see here, I go through my whole thing. Yeah, so here, you're going to see here, I then would write the results to my Google Drive and it would store the results in my Google Drive. But yeah, to your point, it doesn't just save it in Google Drive automatically. So that is an added step. So if you're working in Google Drive, you do have to be aware of that and you do have to account for that. So yeah, great question. There's one other sort of text-based thing I want you to be aware of, and that is YAML. So YAML, I'd be surprised if any of you have heard of YAML, but YAML is also a very popular serialization thing. It stands for a bit tongue-in-cheek. It stands for it's a recursive acronym. It stands for YAML, stands for YAML ain't markup language, and it's a really nice simplified thing here. So you can sort of see here where you have sort of field value, and then you sort of have nested lists, and within the nest list you have field values, and it's a really nice kind of streamlined, very simplified way of doing kind of, again, structured nested data. YAML, and the reason I mention YAML specifically is that it is a very common way of doing config files. So I don't know if you guys are familiar with config files, but most programs, as you can see, like they come with certain libraries, dependencies, program settings, things like that that you need. And so oftentimes they will include a config file that basically sort of tells your Python environment, okay, here's the settings that you need to tune in order to make sure that this works properly. So that's what a config file does. And YAML is very typically the kind of go-to configuration for config files because as you can see, like it's a very simple, very readable thing. And again, there's specific libraries for it. I think you're sort of getting the pattern here, right? It's kind of your import in this case a YAML thing. You use a with open statement here. In this case, it'll be a YAML load to get your different things. Um, so yeah, I think it's also a load dump sequence for YAML, but yeah, pretty much the same syntax as with JSON. But yeah, I did want to mention that as another um, sort of readable serialization file. And by the way, and then there's kind of a reason I'll mention readable versus not in a moment. Any question on that? So the final thing I'm going to mention tonight is going to be pickling. Don't ask me why it's called pickle. I don't know. Someone was having fun with that one. Python supports its own version of serialization, and that's called a pickle. What pickle does, which is really interesting, is it actually sort of breaks down. It's a binary protocol. It um, it sort of converts a sort of hierarchical data structure directly into a byte stream. So you may remember that Python, right? The Python interpreter basically kind of breaks down sort of a high level human readable programming languages ultimately into bit code, zeros and ones binary that essentially is computable, computer executable. Um, and it obviously does it for code, but it can also do it for data. And that's what the pickling process is. Essentially, when it does pickle, it converts your human readable data structure into a byte stream object. And then it stores it. So it just kind of stores it in bitcode that way, as pickle files. And so you can literally, and again, just like everything else, you pickle load and you pickle dump. So you can take a pickle file and load it, and it will sort of unpack it and convert it into a data object. And then you can do a pickle dump, and again, it takes a data object in your thing and does it. And in fact, I think I just show you that, I believe. Yeah, here, why don't we just quickly do a quick example of that. Which one do I have here? So I think I just have data, right? So people data equals pickle dump data. Yep. Ooh, really, pickle's not defined well. Do I need to import pickle? I thought that I didn't. Well, let me see here. Maybe I do. Okay, I did. And so you'll see here, now I have a people pickle file. And the interesting thing here is if I try to open this, you'll see here it kind of looks like a bit of a mess because again, this has been converted. This is not designed to be human readable. This is designed to be bitcode that is sort of directly parsed by Python. Again, this is static storage. It's also compressed storage. So it's actually it's a much more efficient data storage thing. But now if I want to unpickle it, I'm going to say unpickled equals, yep, pickle.load. Yeah. And by the way, the WB and RB, um, it's write and read, but it's write binary and read binary. So that's the little notation that I want to kind of call out to you. Unpickled is just that. And now if I look at it, here's my data structure again. So yeah, so that's pickling. Nothing too exciting, but big differences as you may have noticed, right? And again, this is kind of the point to note here. JSON, XML, CSV, YAML, right? Those are all text serialization things. It outputs to Unicode text. So it's something that's still readable, right? You can open it like I opened it directly in my IDE. I can open it as a text file, right? It's just plain Unicode text. Um, Pickling obviously does not, right? It's bit code. It's not openable. The other thing to note is that most of these other sort of text serialization things are interoperable and they're widely used outside of the specific Python ecosystem. Like again, JSON is kind of the default information exchange medium online. Like if you're sending any data, it's typically in a JSON format. And again, it could be to Python, it could be to JavaScript, it can be to anything. JSON's kind of the default. Python is very, very Python specific, obviously. It's Python's native mechanism for serializing objects. One thing to note is, and this is true for any compressed file, right? When something is compressed down to um, to machine code, is it's kind of a black box, right? You don't necessarily know what's going to kind of come out of that box. So, so one thing to note is that JSON generally does not sort of create potential arbitrary code vulnerabilities, right? You can't sort of insert malicious code into JSON. It's readable, it's parsable. You know what you're getting at, right? Pickle, You have no idea. If I give you a pickle file, again, it's just like if I give you, right, if somebody just hands you a zipped file, like, oh yeah, open this on your desktop. I promise I'm up to no good. I promise it's all candies and butterflies, and you're like, yeah, I think I'll pass, right? So same idea with the pickle file, right? It's trusted source. If it's you or it's your family, sure, you can unpickle that pickle. If some random person on the stranger's like, yeah, here's my library, I pickled it for you. You may be like, I'll think twice about opening that up within my environment because again, you could get malicious arbitrary code execution if you unpickle an unknown file. So just kind of a little note there. Okay, any questions on that? So far, so good. All right, well, congratulations, guys. We have come to the end of the line for Module 3, Best Practices. So you do have a lab for this week. I'm going to pull that up right now. So you'll have good amount of time to work on it. It'll be obviously, get to work on this week and obviously you have spring break. I hopefully you will not have to work on it over spring break, but yeah, you do have that time if you need it. So unsurprisingly for today, topics are going to be serialization and error handling, um, modules, and yeah, pretty much that. Yeah, I mixed error handling and serialization together. So let's kind of look at this. So the first thing you're going to be asked to do is define a function called pickle data that will take in two inputs, a data structure within your Python program and an overall file name. The function should read in the data and dump it to a pickle file named whatever the file name input was. And then I note for complete credit, wrap the pickling in a try except code block and ensure that it functions robustly. So if an exception is raised, have it return an error occurred while pickling the data. Um, so yeah, so you might see sort of an example. So you'll see here, like uh, I test this. Um, so one thing I'll know here, so here's this sort of a sample thing. You have a little dictionary thing. That's going to be what you're going to pickle. Um, you see here you might see in the test things, I pass in books info thing there, so that should work. And then for this one, it's not going to work because pickle itself is not defined. And so that should return an error has occurred. So you just want to get these outputs. Just do these return statements. Again, either a try except, right? Either it pickles and then it returns this, or it doesn't pickle and it returns that. Um, So now for exercise 2, I ask you to unpickle data, and that was going to take a pickled file and unpickles it, right? So the inverse of that, an existing pickle file, it should return the data. And so, and then again, wrap it in a try except block. And for this one specifically, I have for a file not found error, specifically have it return that, and then grab all other exceptions. And you just do this as, again, an if and then a except file not found error, and then just an except block for everything else. Then just say an error occurred while unpickling the data. To run that, again, it's going to be unpickle data is going to be what you're doing. I'm going to load the pickle, whatever the pickle file name here is. I'm going to try to do the assertions. Either it's going to work or it's going to not work. And yeah, so I'm going to test that. Finally, for this, I'm going to ask you to do a JSON related one. So I'm going to ask you to create a function parse data that takes in a JSON file. This is provided right here. There's a students.json file, a very basic students.json file here. So you're going to download that. You're going to load it into your Google Colab notebook. So you may have seen me doing that, but again, here you have a file manager for your Colab notebook thing. So you can upload it directly here. So a little dialog will pop up here and you can sort of upload it there. So upload the file and then just create a function, again, parse data that takes that in as input and is going to store, right, is going to return the data structure. So, so yeah, so that's what I'm going to ask you to do for those three. So those are going to be your serialization and error handling work. And then for modules, so this is something I want to sort of mention for this. Um, I'm going to ask you to create a calculator module, and you're going to call it calculator.py. And by the way, for this one, you're going to need to create this outside of Colab. And what you're going to do is you are going to then create a calculator.py file on your desktop. You're going to then load it into here. Okay? And then what's going to happen is so you're going to notice here for all my assert statements, there's going to be, I have an import calculator. So again, assuming you've created the calculator file, and by the calculator file will have, you can sort of see here, there's basic arithmetic functions, right? Add, subtract, multiply, and divide. Add, you should add two numbers and return the result. So it should take two inputs. Subtract, again, same idea. Multiply two numbers, divide first number by the second number. Um, and then do a little error handling where you have it return an error division by 0. So do a little error handling there if you get a 0 division error. So after you've created that file, I want you to then load it into here so that when I run this line here, this cell right here, and I do the import statement, it's going to import the calculator module that you have created. And you'll notice these assert statements, they all run on these methods here. So calculator.add, calculator subtract, calculator multiply, calculator divide. Okay, so that's where I'm going to sort of see those. Now, because when you submit this to me, your calculator file will not be here. I can't necessarily see the raw calculator file. I'm going to ask you just to validate it that you do two things. One, I want you to just drop your methods right here. Now, again, these methods aren't going to directly work, right? If you do a def add num1, num2 here, it's not going to work because, again, my assert statement is looking at calculator.add. So in order for this assert to work, it needs the calculator module to be imported. Um, so the first thing I'm going to ask is just drop those functions there just so I see you did them, and then run this cell, because if you run this cell and all the asserts pass, I will know that when you ran this, you had a calculator.py loaded here and it worked, right? Because I'll get all the asserts will pass, it'll print exercise 4 is correct, it'll increment your score. So if I see that and I see the methods, I'll be like, yeah, good job. You did what you were supposed to for this one. So, all right, that's what I'm looking for this week. Any questions on that? Okay, cool. Well, guys, thank you so much for hopping on tonight. That's all I've got. A reminder, next week is spring break, so you are off. Hopefully you will not be doing any work, but yeah, hope you have a great break, and I will see you in 2 weeks.